Hi students. So from today we are going to discuss the important questions from the point of view of the CBSE board examinations 2026 maths paper. So first we will be discussing the MCQs from each chapter, and after that we will be focusing on the long answer type questions. So let's quickly start with the first chapter, that is real numbers. I am focusing first on the MCQs because MCQs are a great way to save time and score marks also. If we know the quicker ways, our concepts are clear, then it's very quick to get the answer in the MCQs and we can save time for the other questions. So let's start with the first question. So the first question is asking which of the following is not irrational. So we have to be very cautious with the wordings. It is saying not irrational. So it's another way of saying which of the following is rational. So we have to train our mind because there are a lot of things in our subconscious mind, and when we read the question, then actually we don't read the question. Our subconscious minds get whatever is stored related to that question in our mind. So we have to train our mind that just focus on what is written, not interpret anything. So it is saying which of the following is rational. And we know if you look at the options, then the first option A is 3 plus root 7. So 3 is rational and root 7 is irrational, and we know sum of a rational and irrational is irrational number, but we have to look for the rational, so this is not our answer. Similarly, the second option, that is 3 minus root 7, it's a difference of a rational and irrational, then again it is irrational. Now if we see the third C option, 3 plus root 7 and 3 minus root 7. So both are irrational and their product. So product of two irrational numbers can be rational and irrational both. So if we analyze the option C, so if we quickly see this, it is in the form of A plus B and A minus B, and we know this is equal to A square minus B square. And in this option, in place of A we have 3 and in place of B we have root 7. So if we substitute the values of A and B according to this option, so it is 3 square minus root 7 square, so that is 9 minus 7, that is 2. And 2 is a rational number, and that's what we were looking for. So our answer is C. Similarly, if we analyze the option D, so it's product of a rational and irrational, so that is going to be irrational only. So here we will be looking for each option, and in paper if we get the answer then we can stop there only. Okay, so now coming to the second question, that is the multiplication of two irrational numbers is. The multiplication of two irrational numbers is what it will be, it is asking. So in the first question only, in the option C, which is our answer, we saw the product of two irrational numbers is rational. So we can see that it will be a rational number, but we don't have to take option B as the answer because there is an option that is it may be rational and it may be irrational also. So we have to be very cautious. If we get the answer, then also go through each and every option. Okay, so the multiplication of two irrational numbers, so we already know it can be rational. Whether if it can be irrational also, then our answer will be option C, and if it's not possible to be irrational, then our option will remain B. So let's quickly see whether product of two irrational numbers can be irrational or not. So in such a case, we have to either prove that it is wrong or we have to prove that it can be a possibility. So I have to find out two irrational numbers whose product can be irrational or not. So if we see root 5 and root 7, both are irrational numbers, and their product root 35 is also irrational. We can Take any two irrational numbers, but we have to keep in mind that their product should not be a perfect square. So root 35 is an irrational number. So product of two irrational numbers can be rational and irrational both. So our answer will be maybe rational and or irrational. Okay. So I hope this would be clear. Now moving to the third question. Third is an interesting question. The least number that is divisible by all the numbers from 1 to 5. Okay. Basically this question was the least perfect square number. The least perfect square number that is divisible by all the numbers from 1 to 5. Okay. So we already know that the least number that is divisible by some numbers is their LCM. So basically I have to first find out the LCM of 1 to 5, and then I have to make that square. So LCM of 1 to 5 will be so the numbers from 1 to 5 is 1, 2, 3, 4 and 5. So if I have to take the LCM, so I have to take the product of all the prime numbers which are present in these numbers. So 2 is a prime number, 3 is a prime number, 4 is a product of 2 and 2. So 1, 2 is already there. So I have to take one more 2, and 5 is a prime number. So if I multiply all of them, I get 60. But 60 is not a perfect square. To make it a perfect square, I have to make the powers of the prime numbers present in 60 as even. So power of 2 is 2, so it is already even. 3 is only 1, so I have to multiply by 1 3 to make it a pair. And 5 is only 1, so I have to multiply by 1 more 5 to make it a pair. So 3 into 5 15, 15 into 60 is 900. So 900 is the smallest perfect square which is divisible by all the numbers from 1 to 5. So our answer is 900. So first of all, what we did, we found out the LCM of 1, 2, 3, 4, 5 and we got 60. But the question was asking for the perfect square and 60 was not a perfect square. So we saw the factorization of 60 contains one pair of 2, one single 3, one single 5. But to make it a perfect square, 3 should have been in pair. So I multiplied by 1 more 3. 5 should have been in pair. So I multiplied by 1 more 5. So it will be 900. Moving to the next question, fourth, that is the decimal expansion of the rational number 23 divided by 2 square times 5 will terminate after. So it is asking after how many decimal places the decimal representation of 23 by 2 square into 5 will end. Okay. So if I write it, so it is 23 by 2 square is 4 times 5. So that is 23 divided by 20. So we will not actually divide, we will try to make the denominator as a power of 10. So we know 20 times 5 is 100. So I multiplied by 5 in the numerator and denominator. And dividing by 100 is quite easy. I don't want to calculate the numerator. So it is 23 times 5 divided by 100. And I know if I divide any number by 100, so there will be 2 decimal digits after the decimal number. So it will end after 2 decimal places. So our answer will be option B. Now moving to the question number 5. Here it is saying if the SCF of 65 and 117 is expressible in the form of 65 times m minus 117, then the value of m is. So SCF of 65 and 117. So SCF is the largest number which divides all the numbers. So if I see 65, its factorization is 13 times 5 and 117 is 13 times 9. So 13 is present in both and there is nothing common in between 5 and 9. So HCF of 65 and 117 is 13. And if 13 is expressed as 65m minus 117, so what will be the value of m? So negative 117 will be brought to the left hand side, so it will become positive. So 13 plus 117 is 130 is equal to 65m, and if I divide by 65 on both the sides, so we get m as 2. Here it is 130. So the value of m will be equal to 2. So what we did in this question, we first found out the HCF of 65 and 117. And how we found out? We factorized 65 and 117 and we got that 13 is the largest number which divides both 65 and 117. And we wrote 13 as 65m minus 117 and then we did the normal calculation to solve the equation. Now moving to the next question, that is sixth question. N square minus 1 is divisible by 8 if n is. So now it's very logical to think if any number is divisible by 8 or means it is a multiple of 8 and every multiple of 8 will be even. Okay. And we know n square minus 1 will be using the formula a square minus b square, it is equal to n minus 1 times n plus 1. So if we assume it as an even integer, if suppose n is an even integer, suppose our answer is D, then n will be an even integer. So n minus 1 will be odd and n plus 1 will be odd, and odd times odd will always be odd. And any odd integer cannot be divisible by 8. So this cannot be our answer. And an integer, so integer can be even also, so this also will not be the answer. Natural number can also be even, so this also cannot be our answer. So only possibility is option C, an odd integer. Now moving to the question number 7. The sum of the exponents of prime factors in the prime factorization of 4004. So we have to find out the sum of the exponents of prime factors in the prime factorization of 4004. So first of all, we have to prime factorize 4004. So 4004, we know it is an even number. So if we divide by 2, so it will be 2 times 2002. Now again 2002 is even, so we can again divide it by 2. So 1001. Now 2 times 2 and 1001 is divisible by 13. So if we divide by 13, okay, let me erase it. If we divide by 13, then it will be 13 7s are 91 and 100 minus 91 is 9 and 1, so 17. So we can write it 2 times 2 times 13 times 11 times 7. So we have to find out the sum of all the exponents of the prime factors. So it will be 2 square into 13 into 11 into 7. So 13, 11, 7 have power 1. So their sum is 3 and 2 has power 2. So 3 plus 2 is 5. So sum of all the exponents of the prime factors in the prime factorization of 4004 is 5. Okay. Now moving to the next question, that is question number 8. It is asking just to simplify this, and after simplification we have to tell whether it will be positive rational number, negative integer or what. So it is a plus b whole square minus a minus b whole square. So if we see this, a plus b whole square minus a minus b whole square. So this is equal to 4ab. So now if we solve this according to this question, in place of a we have 1, in place of b we have root 3. So that will be equal to 4 times 1 times root 3, that is 4 root 3. So it is a multiplication of a rational and an irrational number. So product of a rational and an irrational number will always be irrational. So we can say a positive irrational number, this will be our answer. Okay. Now moving to the next question, that is question number 9. A number when divided by 61 gives 27 quotient and 32 as a remainder. So we have divisor, quotient and remainder, and we have to find out the number that is dividend. So we know the relationship. We write dividend is equal to divisor into quotient plus remainder. So dividend we have to find out. Divisor is 61 into quotient is 27 plus 32 is the remainder. So 27 1 ja 27, carry over to 162, 164 plus 32, that is 1679. So this is our answer. So dividend is equal to divisor into quotient plus remainder, and we had to find out dividend. So divisor was 61, quotient was 27 and remainder was 32. So we multiplied and simplified and we got the answer 1679. Now moving to the question number 10. If x is equal to ab cube and y is equal to a cube b, where a and b are prime numbers, then HCF of xy minus LCM of x comma y is equal to. Okay, so we know HCF is the prime numbers present in both the numbers with the least power. So x contains a, y contains a cube, so least power is a, that is a to the power 1. X contains b cube and y contains b, so least power is b to the power 1. So HCF is ab. Now I have to find out the LCM. LCM is the prime numbers present, all the prime numbers with their highest powers. So x contains a and y contains a cube, so I have to take the highest power, so a cube. X contains b cube, y contains b, so I have to take the highest power, so b cube. Now according to the question, HCF of ab xy, that is ab, minus LCM of x comma y, that is a cube b cube. So ab is present in both, I can take common, so it will be ab minus a square b square. So I can write 1 also as 1 square, so that will be ab, a square minus b square, so a minus b and a plus b. So our answer is option D. Now question number 11, it's a very easy question, but yes, there is a lot of chance in making mistake in this, as I know 4 is a perfect square, so it may be possible to think it as a 0.2 square is 0.4, but I know 0.2 times 0.2 will become 0.04, not 0.2. So 0.4 is not a square of any number, so I can say it will be an irrational number. And if you want to look, so I can write 0.4 as 4 over 10. So that will be square root of 4 over square root of 10, that is 2 square root of 10, and that will be an irrational number. Now moving to the last question, question number 12. Which of the following cannot be the unit digit of 8 to the power n, where n is a natural number? Cannot be the unit digit of 8 to the power n. Right? So if I see 8 to the power n, we can write it as 2 cube to the power n. So that is 2 to the power 3n. Now I don't know what will be the unit digit of 2 to the power 3n, but we know that for 0 to be the unit digit, there should be at least one pair of 2 and 5. But in the prime factorization of 8 to the power n, that is 2 to the power 3n, there is no 5. So 0 cannot be the unit digit of 8 to the power n. So our answer will be C. So I hope all the questions whatever we discussed would have been clear to you, and if there is any doubt you can just leave that as a comment. I will try to answer that. Thank you for your patience and have a nice day.